Hi guys, welcome back to Learning Electronics Repair. This is the power supply out of this 10 kilowatt audio amplifier I'm repairing. So the previous video we had a look at the amplifier. We know what we need to order for that one, and then hopefully that one works. I mean, I didn't test everything, but I worked my way back from the short circuit output transistors and the MOSFET into the circuit as far as where I could see that the components driving were okay. So once you get that far back, then you probably isn't much point going further back, but we will see. So this is the power supply. Now we know there's a short on here because we had a quick look on the original video and the short was around here. Okay, there is a board with the inductors and capacitors, filter inductors and capacitors on the input to this. Okay, that feeds into the bridge rectifier. That's another board, and on there were two fuses and one was blown. I see two more fuses down here, so we can have a quick look at those as well. What do we have? Well, that reads okay, and that reads okay. This is the low voltage side of the power supply. So these are all your smoothing capacitors on the output. There's two probably rectifier diodes down there. We can have a look. Yeah, we can see they're 2-pin devices, so rectifier diodes. Smoothing capacitors all in parallel. Okay, and this is the high voltage side of the power supply, and this is where we have the short. And from what I saw previously, these are reading short. That actually reads a low resistance. These read short. It looks like these are all in parallel again. Okay, and these devices 40N120, so they sound like they should be MOSFETs. These are under here. We see this heatsink, so we can see D3, Q1, Q2, Q3, D6. Okay, only one of those diodes is actually on the heatsink. Let's look at it, which is this one. That reads like a diode. Actually, it reads like a diode both ways. Well, that's probably something to do with the short. And that is D3 from what I can see on here. I'm not sure where D6 is actually. Maybe it's tucked down here somewhere. It's not on this heatsink. Okay, let's have a look at the schematic. And as I mentioned when we look at the amplifier PCB, I can't say this is exactly what we have here, but I think it's very similar. And here we see basically a block diagram, 10 kilowatt flyback. I have an interesting point here. So this amplifier, 10 kilowatt, it runs off a normal mains lead. So I believe a mains lead can supply 14 amps maximum. I won't do the conversion from AC to DC, but 14 amps, that's 240 volts. There's about 3,300 watts, so I honestly don't see how this supplies 10 kilowatts. Discuss. And it's not Chinese, it is Swedish. Okay, so we're talking Swedish watts here, not Chinese watts. Now then, these are these big devices, Q1, Q2, Q3. This is where I see a short. D6 is here, so that's across the MOSFET, so that could be short, or these could be short, or it could just be one of them. Okay, and these are really unusual looking devices. Look, like an emitter in and an emitter out in the dash. I think, oh yeah, gate. So these are IGBTs. Okay, gate collector emitter. So that's what they are. They're all in parallel, and then the current which is come in effectively from the bridge. Let's see, so this is your bridge rectifier, this is ground, this is your positive, supply through the primary. So I don't see a PFC circuit as such on here. Yeah, straight down to these, through here, through all these resistors, back down to ground. So that's where the current flowed if these are short. Okay, so what's likely to be damaged? Well, first of all, let's figure out what is short, and then we probably need to have a look at what's driving this. Okay, and that looks like it comes from this module, which could make this difficult to repair. Let's see. Okay, what I was reading from the gate to collector emitter, I was reading a short there, and then I was reading like some sort of resistance. I think that's this 2.2 ohm I'm actually reading. Okay, I'll get this stuff unsoldered. This looks like it's constructed the same as the amplifier. I've just unbolted this one. It was bolted down, of course. So these shouldn't be too difficult to remove. I'm going to take just the diode off first, and then we can see if there's still a short here. So I've added a bit of flux. This is where the big chunky soldering iron comes in, guys. Some leaded solder. Okay. This may be a bit hot now, but I'll lift it up, and then we're just kind of like, yeah, you see how I lifted one edge, other edge. Be careful not to rip the tracks off the board. See, that one's unsoldered now. Yeah, out it comes. Let's just check that. So reads open, reads like a diode. Okay, I'll put that one back on shortly, but let's get these other ones off. So these have obviously 3 legs, but they're not too much more difficult, really. They're not too tricky. In fact, the heatsink is going to come off. Yeah, that just dropped off. Nice copper heatsink, that. I'm sure this thing was quite expensive, this amplifier. Okay, same technique. I have a bit of leaded solder. I'm going to try and slide this backwards, see if it'll come off. Just get all the legs together, all heated together. Yeah, those lifted. Okay. They've lifted, but they're still soldered down. So let's try something like this, because the solder shouldn't stick to this. Okay, just give it a second. Solder solidifies. Again with this one. Just get under. Yeah, it looks like I'm under it. Yeah. I think that's all desoldered. I'm not sure if it's just soldered. Yeah, there you see. Now I'm under it. Okay, try this one. Yep, it fell off, pretty much. Okay. No damage to the PCB, that's the main thing. Short to the gate. Okay, so these are shorted. Well, that one is. This one isn't. Let's try it on the components analyzer. And this one isn't. So only one is actually short. I would be tempted to replace all 3. And let's see if this will test IGBTs. I'm not sure this actually does. Yeah, I just think this is diode junction. Could be faulty. Could just be that this won't test the IGBT. In fact, thinking about it, I've tried this with IGBT before and it says diode junction, so I guess we need an IGBT tester. What do you think, guys? DIY or buy one? Okay, we'll do that in the future. Let's see if there's any shorts still on our amplifier power supply. And let's make sure all the tracks are fine after that, okay? Okay, so I'm thinking now the short has probably gone. Yeah, that reads like a diode. Because of stuff in the circuit, that reads like a diode. That doesn't, that's interesting because they're in parallel, I think. Oh no, it doesn't look like a diode. Look, it's going up, yeah. That looks like a diode. Let's come this way. Yeah, it wasn't a diode, it was capacitor charging. Now we can see. And that isn't a short. Again, capacitor charging. They're all in parallel, so they're all going to be the same. Okay. So, what else might have been damaged? Well, the current obviously came in through the bridge rectifier. This link here was already there, by the way. Okay. Not sure why, but this is definitely where the AC comes in. So there was no short on the bridge rectifier. That tested okay. This goes to the transformer here. So power comes in to the transformer, back out the transformer. We know that goes to here. So we have all these low value resistors to hot ground, which are here, okay. Each one is 0.1 of an ohm, and they're in parallel, okay. Well, if there's 10.01, if it was 5.02, so it's around that, yeah. What do we see? No point trying to measure them all because they're all in parallel. But I could use the low ohm meter. So they read pretty much 0. Let's see what this says. Just 0 that. Okay. Yeah. 17 milliohms, and I said it was going to be a bit less. If there was 5 of them, it would be 20 milliohms, so I'm sure that's just fine without getting the calculator out. Yeah, obviously the current came through the primary of the transformer, and that reads like a short, so you expect that's probably okay. Probably could have shorted turns on it. And this is that module thing, which maybe isn't quite so bad if we have to work on it. Okay, so we know we have a short to the gate on at least one of these, okay? And that comes back into this driver, this module, which we could work on. It's not like all gummed up in glue or potted. So the gate drive comes via these two transistors here, okay? BC327, BC549. So Q5 and Q4, there's a resistor in there, and that drives the gate. We should also have a look at this gate drive resistor as well, the 2.2. Let's check these two transistors. If these look okay, then probably this module is okay because it's effectively protected by these. So Q4, Q5. Q4 is the PMP. And BC327, I'll just check the pin out. Yeah, the base is in the middle. Okay. And the other one? Same, with the base in the middle. Okay, what do we have? Well, one of them was a PMP. That means a junction. That means a junction's 580, 592. So this should be the emitter. And then the other one, NPN, 637, 627. So again, emitter. And then the two bases are connected together. And emitter of one goes to the emitter of the other via the 100 ohm. Okay. So base to base. Yes, connected together, and emitter reads 100 ohms. Okay, that's good. So you know when you're measuring these, when you see the junction from the base collector, base emitter, whichever one has a higher reading between the two is the base emitter. In some transistors it's basically the same, but most of them there's a fair difference like we see here. Okay, so that resistor is okay, they're connected together. The transistors are okay, and then we just want to check these 2.2 ohms, although only one of them was short. So let's have a look. So R2, R3, R4, which are right down where we actually are anyway. I'll put my meter onto the low ohms range. Just hit calibrate. Okay, and these are 2.2s, so let's have a look. So this one, yep, 2.2, 2.2, 2.2. Good. Anything else I see I should be checking here? Well, we mentioned this diode across collector emitter of Q4 with the positive lead onto the collector. Or we could just find the diode, which is right next to the transistor anyway. So this is a Zener, so it should read about 0.7 on diode range. But some read more like a normal diode. Yeah, 618, that's fine. So I don't see anything else in the direct line of fire when this thing went short. In that case then, let's look for these IGBTs. This diode was effectively reverse biased when this failed, so I'm sure that is absolutely okay. And all the resistors look fine. Okay, just RGBTs on this one, I think. And these FGL40N120. All the same. So there's a few sellers of these. 487 sold here. I've bought from this supplier before. Okay, so I can get 6 pieces. I mean, that's 2 sets for about 25 euros. A bit of postage. They're a bit more expensive, these, but I think I'd probably be happy to trust those. Okay, there's another supplier here. Yeah, same part, 10 for 16 euros. So I have a few options. So we'll add these to the shopping list. This is not going to be a particularly inexpensive repair from what I've seen already. I'd probably end up with 40 euros or something of parts. So this one's going to go some way over 100 euros to repair. Yeah, probably quite a way because of the amount of work it took to get the thing apart. And I have to do some more work when these parts arrive. So firstly, I need to replace these IGBTs and I need to power this up on the bench. I can do that. I can actually power it up, get some mains into it and see what it does. I want to be sure that this is actually running and giving a suitable output voltage first. Okay, once I know this is running, then obviously I need to repair that amplifier channel. I'll replace the parts I know are faulty and I'll make a more in-depth comparison then between that one and one of the known good ones or assumed good ones. If it all looks okay, I will connect it up basically and let's see what happens. Yeah, we put the light bulb in series with this, although it may well not help us. If something breaks down once all this lot are pretty well charged up, they're going to discharge into it, yeah, and the light bulb will not save us. But you know, that is probably the best approach. I could, if I really wanted to, in the plus and minus 160 volt off here is connect two light bulbs, one in each of the voltage rails, the plus and minus, from the power supply to the amplifier boards. I can also test those amplifier boards, at least power them up on the bench once I know this is running. So I'll get the stuff ordered, and then we have a nice methodical way of checking if everything is okay before we put it all back together. And while I'm just looking at this, one other thing I really feel the urge to test is the rectifiers on the output, because a short here would cause the power supply to blow, but we already know there's a shorted channel anyway. But again, all that current's come through here, yeah, so it's come through here. Let's have a look. I see a capacitor charging. These are probably Schottky diodes, I would imagine. Let's see how far it goes. If it doesn't stop, we'll go the other way. Okay, it's still going. Let's go the other way. I'm not sure which polarity, so wait till it just discharges the capacitor. That's a diode. Look, it's got it there, yeah. Not that way round. And not that way round. I might have an open circuit diode. We should remove this as well. And I was absolutely correct. Yeah, look at that. I think we can say that's blown. So that's probably the last thing that's in the direct current path. Are these the same? Well, that's a good question. We've got to hope the schematic is going to tell us, because you can't read that. That's a number difference. Okay, at least we can read that. Let's look at the schematic. So D14, that's just a component reference. STTA 3006PI. STTA 3006PI, just connected the opposite way round. So they are the same. The one here kind of looks a slightly different number, so let's make a note of this one. SDUR30Q60W. And this I'm having a bit more trouble finding. Okay. What was the port number on the schematic? Okay, this one, STTA 3006PI. That thing. And well, I can get those. They have the metal tab. Yes, here in the same package. Okay, so I will check the data sheet, but I'm assuming pretty much they are the same, because, well, that's what the schematic says. Get 5 pieces there. Okay, so that completes the shopping list. So guys, I hope you see, this is not like a random repair method. This is figuring out what the current path is, what went short, we know, off the first video, and then kind of figuring out, okay, where did the current flow out of this into there, that way, because I'm flowing the wrong way, okay, this way. And from that, you can work out what to test, and that's how I came to test those two diodes down there. I couldn't see the damage because they were buried down here on this heatsink, okay, so it wasn't visibly obvious. Maybe if I had really looked down there I might have seen it, but I think I found it by a much better method, which was figuring out, A, I need to test these, and then B, it looks like it's open circuit, and it was. Very. Okay guys, so this needs a lot of parts. This is going to be quite an expensive repair. I'm interested just to see how much these things actually cost, these amplifiers. Well, these are the FP-10Q. I mean, mine says FP-10Q on, so I'm not sure exactly which model it is. I've searched for FP-10Q and it kind of brings me to this. AliExpress sell them? Oh no, they don't, but he said they're like over €1,000 if they did. So I think this one is likely, by the time I've got the parts and all the work involved, it's probably going to be heading €200 this repair. I wouldn't be surprised, it's just a lot of work involved. So yeah, I think it's going to be somewhere in that region, this job. But I mean, we're probably talking like an €800 to €1,000 amplifier, something like that. So I guess it's worth it, yeah, if we get it to work. Okay, so hope you enjoyed that one also. and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.